Welcome back to The Explainer. Okay, I want you to just think about this for a second. Tonight, when you're lying perfectly still in your bed, completely dead to the world, your brain is actually going to be burning almost as many calories as it is right this very minute. It's wild, right? We spend roughly a third of our entire lives asleep, and yet the second the lights go out, we just kind of assume our biology takes a well-deserved break. Well, today, we are going on a really fascinating journey into the bustling, electric, and honestly surprisingly busy activity of the sleeping brain. We're going to find out what actually happens the moment you drift off.
To really wrap our heads around this, we first have to debunk the single biggest misconception out there. Is your brain actually resting? Now, historically, early scientists literally thought sleep was just the brain turning into this dormant, bloodless sponge. Seriously. They look at a peacefully resting body and just assumed the mind had powered down. Kind of like snapping your laptop shut and putting it in standby mode. And hey, it's an easy assumption to make, right? We lie perfectly still, our breathing slows way down, and we completely stop interacting with the outside world. But, as we'll see, modern neuroscience paints a vastly different, far more dynamic picture of what goes on in the dark.
Far from shutting down, your brain actually springs to life. When you drift off, it doesn't flip some magical off switch. Instead, it kicks off a massive biological shift change. In fact, specific neural pathways actually become more active the moment you lose consciousness. Take the thalamus, for example. It's a critical relay station in your brain, and it essentially locks the doors to the outside sensory world, physically blocking out external noise and light. This absolutely crucial step seals off the environment so your brain can begin what is arguably the most important job of your entire day, all completely behind the scenes.
So this nightly shift change happens in 3 highly structured steps. First up, we enter deep sleep. Second, a highly specialized cleaning crew activates. And third, we transition into the famous REM sleep. Each one of these phases serves a super unique, absolutely non-negotiable biological purpose.
Let's look at deep sleep. It acts as both a biological builder and an archivist. As a builder, it kickstarts intense physical recovery. It does this by triggering your pituitary gland to release bursts of human growth hormone, which gets right to work repairing the tissue and muscle fibers you wore down during the day. But at the exact same time, it's acting as an archivist. Think about it. All day long, your experiences are temporarily held in the hippocampus, which is basically a short-term storage center. During deep sleep, those important memories are actively transferred over to the neocortex. It literally locks them in and preserves them for the long haul.
And this whole process perfectly highlights a daily problem and a nighttime solution. See, all day long, simply by being awake, thinking, and just functioning, your neurons are constantly firing and burning energy. Now, this process naturally produces toxic metabolic byproducts. The big ones are proteins called beta-amyloid and tau, which you might recognize are the exact same proteins associated with Alzheimer's disease. It's just a natural consequence of a working mind. But obviously, you can't just leave microscopic waste sitting around in your head. So daytime is for accumulating this toxic clutter, and nighttime is for the highly active, vital process of flushing it all away.
Which brings us to the cleaning crew, the glymphatic system. This is essentially your brain's biological night shift. And it isn't just passive draining either. The glymphatic system is an active, highly specialized plumbing network that really springs into action during deep sleep. Get this, the glial cells in your brain actually shrink by up to 60%. This creates wider channels so that cerebral spinal fluid can literally rush in. It acts just like a biological power washer, actively scrubbing through the brain tissue and flushing away those toxic beta-amyloid proteins. It's basically sweeping the floors and taking out the trash, making absolutely sure you wake up with a clean slate.
Now, this nightly routine doesn't happen in a straight line. It operates in dynamic cycles that last roughly 90 minutes. Around the first hour of a cycle, you plunge right into that heavy deep sleep phase, where all that physical cell repair and the intense power washing of the brain tissue begins. But then, as we move through those intervals and push later into the 4- and 7-hour marks of the night, the architecture of your sleep changes dramatically. Your brain is essentially riding a continuous roller coaster, transitioning out of deep physical repair and surging into a highly energized state, REM sleep. And this is where the vast majority of your dreaming actually happens.
And here's the craziest part about REM sleep. Your brain is almost as active as it is during the daytime. I mean, if you were to hook a sleeping person up to an EEG monitor during this phase, their brainwaves would look almost completely indistinguishable from someone who is wide awake and intensely focused on solving a complex math problem. Your eyes are darting back and forth beneath your closed lids, and inside your skull, your brain is just firing with intense electrical signals.
Functionally, your body is paralyzed in bed, sure, but cognitively, your brain is operating with nearly the exact same level of energy as it is right now while you're listening to me.
So what is all that REM energy actually being used for? Well, it dedicates massive computational power to processing the day's emotional events, really untangling how you feel about your experiences. It also severely boosts creativity by forging new, totally abstract connections, which, by the way, is exactly why your dreams can feel so incredibly bizarre sometimes. But most importantly, it meticulously organizes everything you've learned. Like if you spend the afternoon practicing a difficult piano piece, during REM sleep, your brain will literally replay those exact neural firing patterns at up to 10 times the speed. It's physically hardwiring that muscle memory directly into your nervous system.
So what happens when we shortchange this incredibly busy nocturnal routine? Look, we all live in a hustle culture that constantly pushes us to stay up later, to binge watch just one more episode, or to cram for just one more hour of work. But when we understand the sheer volume of mechanical and cognitive maintenance happening behind the scenes, we really have to ask ourselves a tough question. Is stealing time from our glymphatic system actually making us more productive, or are we just straight up sabotaging our own biology? Because when you don't get enough sleep, you aren't just feeling a little groggy. Your hardware is actually malfunctioning. Without adequate deep sleep and REM cycles, your internal power washer simply doesn't finish its cycle, and your emotional processor gets cut off halfway through. In the real world, an altered mood means snapping at a coworker over a totally harmless email. A delayed reaction time means being a critical fraction of a second too late to hit the brakes when traffic suddenly stops. Even just one single night of poor sleep severely impacts your memory retention and problem-solving skills. You're basically trying to operate a highly complex machine that skipped its critical nightly maintenance.
Ultimately, what this tells us is that sleep is absolutely not a passive surrender to the night. It is an active, vital investment in tomorrow. Every single night while you're lying there in the dark, your brain is working tirelessly to repair cellular damage, flush out dangerous neurotoxins, and organize your scattered thoughts. Your entire potential for the next day, your creativity, your patience, your physical health, is entirely dictated by the quality of the repair work that happens tonight.
Sleep isn't just rest. It is quite literally one of the most powerful biological tools you have to keep your mind and body healthy. I really hope this explainer fundamentally changes how you view your nighttime routine. So, the very next time you're tempted to stay up just a little bit later, ask yourself, are you sacrificing your future self just to stay awake an extra hour today, or will you let your brain do the one thing it desperately needs to keep you sharp? Thank you so much for exploring this with me, and I'll catch you on the next explainer.